Hello everyone and welcome to our ECCV2020 workshop talk. My name is Andrej Texler and I would like to briefly present to you our paper, Interactive Video Stylization using Fusion Patch-Based Training, which was done as a collaboration between CTU in Prague and SMED. Our motivation was to help artists in the tedious task of creating hand-painted animations. Last year, we presented a paper on stylizing videos by example. From the given sequence, in this case an Alaskan guy in front of the green screen, we select one frame and let the artist paint over it to produce an exemplar from which the hand-drawn style will be propagated to the rest of the sequence, while preserving high-frequency details and maintaining temporal coherence. While this approach is able to deliver state-of-the-art results, there are drawbacks which make it difficult to use in a real production environment where interactive feedback is inevitable. It's computationally extremely expensive. For longer sequences it may take hours. It's sequential, meaning to stylize the current frame, the previous frames needs to be processed first. And last but not least, in the case when there are multiple stylized keyframes available, an entire video has to be processed from the first keyframe and from the second keyframe individually. Then an explicit blending operation needs to be performed. Our aim is to preserve the high visual quality of the previous approach. However, at the same time, we'd like to achieve early-time inference, allow for random access to the individual frames, and avoid any explicit magic of sequences stylized using different keyframes. In fact, we would like everything to be as implicit as possible. To approach this challenging task, we draw inspiration from the recent success of image translation networks, in particular FaceStyleGAN by Fujik and his colleagues. This approach is capable of delivering high-quality stylized results in real time, but it requires a huge dataset for training. When we apply FaceStyleGAN directly on our task, meaning we train the image translation network on a single training pair, the network, of course, strongly overfits to the single training sample, and the results are of poor quality. When exploring the field of deep internal learning, we got inspired by recent published work of Zhou and colleagues, and derived a patch-based training strategy to simulate large dataset needed by FaceStyleGAN. From the input image, we randomly sample small patches. We run the patches through the network. We sample the patches from the same corresponding locations from the output image, and we compute the loss between these patches and we backpropagate the error. During the inference, since we aim for interactive inference speed, we cannot do this on patches. But thanks to the fact that our network is fully convolutional, it only has convolution layers, we can take entire input image and pass it through the network. Moreover, since we do not have any data dependency, we can stylize an entire video in parallel or have multiple images in a single batch. But it was not working just yet. We needed to solve two more issues. First, we needed to tune the hyperparameters, but we didn't have any ground-truth data to validate our network on. We just had one hand-painted style exemplar used to train the network. And second, we needed to enforce temporal coherence so that the resulting video does not flicker in time. To do that, we use a motion-compensated bilateral filter and we propose a new auxiliary Gaussian mixture layer. Unfortunately, we do not have time to talk about this now, so please refer to our original paper for more details. And once these two issues have been solved, we are able to generate stylized videos of high visual quality and temporal coherence. And now, I'd like to quickly show you some more results. We compare each sequence with the approach of Jamriška and his colleagues to ensure that we provide comparable visual quality and temporal coherence, while we offer fast inference, random access to the individual frames, and interactive experience. Since our approach is really fast in terms of both the training speed and the inference speed, it allows us to come up with various interactive scenarios, which are very engaging for artists. Here, my colleague pre-recorded herself. She printed two keyframes on a stencil and now, while she is painting, the training and inference runs, and a pre-recorded video sequence reflects the newly painted changes on the fly. And now, she just switched to the second, side view keyframe. Note that our approach handles multiple keyframes implicitly. In this setup, a live feed from the video camera is being stylized while my colleague is digitally painting over one captured keyframe in Photoshop. So, if you are interested and you want to learn more, please check out the project page for source code, more videos and other material. Thank you very much for your attention.